You can
the
you can
recording.
add this. Yeah, you can add this topic in your the recording part.
Yeah. So the most important reason why we choose the distributed architecture is, supposing if you are on a monolithic approach. Now, i- most of the development companies, they actually recognize that the reporting part is the most heaviest, most hungry resource consumption in the application. But what will happen is that if there are so many user generating reports at the same time, it's actually slowing down the whole system, even for those people who are just viewing the records or entering data, because they are inside one single application. But in a distributed architecture, you can actually put the reporting service in a separate machine, and it doesn't affect for just users who are doing basic data viewing or data entry. So that's the concept of distributed architecture. But anyway, we will discuss that later on. So we will start. Today's session will be about designing Service API. And then we will also go through the idea why we choose to develop in a microservice architecture. But again, as I pointed out earlier, we divide the subject matter into different sections. So if you have some questions at any point in time, please feel free to ask. Just interrupt, just raise your hand or whatever. Just ask your question at any given in time. Is that clear?
Yes, sir. Clear.
Copy.
Thank you. Now, the most important thing when we design an application, not just an architecture, not just a front end, but not just an API, is about security. But first, I would like to ask, by the way, this kind of presentation is actually interactive. So I may ask some questions to the group, or the group may ask some questions with me, but this is just a way of interacting with the presenter and the audience. Now, I think most of you are already developers, so you're already familiar with developing applications that involves security. So just a quick questions to everyone. Anyone can answer. What do you think is the difference between authentication and authorization?
Um, Sir Alex, I think for me, authentication is when you need the username and password to authenticate to
Okay.
the database. And I think authorization is, uh, I think, isn't that when you send a token to authorize, or
Okay.
is
So
it, maybe?
that's a very valid explanation. But in general, a lot of people actually got confused. What is authentication and what is authorization? But it can be actually explained in a very layman's term. Authentication is question about who are you, who is the person, who is the user logging in. While authentication is what you can do. So if I know that this is Josephine Nang, this is authentication. But what can Josephine Nang do is authorization. For example, can Josephine Nang create a new purchase order? Is she allowed to delete purchase order? Is she allowed to print an invoice? What things Josephine can do is authorization. You are authorized to do what? Okay? So a lot of people got confused. So this is very important when it comes to security, because this involves, later on I will explain, involves credential. So once you log in, you will be authenticated, and then you will be authorized using the token. I think you mentioned about the token. That's a very good point. So just to be clear, because later on we will be discussing about this topic. So authentication is identifying who the person is, while authorization is what the person can do. So you are authorized to do this, or are you authorized to do that? Okay, is that clear? No question on this part?
I'm clear, sir.
Okay, that's very good. Now, when we are talking about authentication, the most important thing is every time you register a user, you will be asked to specify a username and a password. Hold on. So when you register a new customer or maybe a new user, you will be required to register a username and password. In most cases, this password are stored in the database. I think most of us already doing that. So now let's try to discuss a very important mechanism called the password storage. Now, I'm not sure if you're familiar. A lot of companies before, they store the password inside the database as plain text. Okay, so what this means, if my password is, for example, COVID-19, it will be stored in the database as it is, COVID-19. That means if somebody would actually go into the database, I can see the password clearly, so I can actually steal the account. Uh, I'm not sure if how does SIOI right now store the password in the database?
Plain text, sir.
Oh, plain text. So in theory, the plain text is the most unsafe mode because once I can get into database, anybody can actually see it as clearly as it is. I can clearly see the password. That means I can actually steal the account. I can log in and do something on behalf of the account. So this is a little bit, it's very harsh to say, but this is actually a very dangerous approach. We used this before, maybe 20 years ago, but nobody store password in plain text right now. It's very dangerous. Another concept of storing password is, I think most of us are familiar, is called encryption. Encryption is we encrypt the password and then store it in the database. Well, this is secured, but not really the best approach. Why? Because once you encrypt, you can also decrypt. Once I know the encryption key, then I can also decrypt, meaning password is reversible, right? So if I can encrypt, then I can also decrypt. Although this is sort of a protected mode, but this is not recommended because of the reversible property of encryption. So maybe 10 years ago, people are still doing this, but today we don't recommend encryption because if somebody would steal the master key, then application gets compromised. Try to avoid encrypted password. So if encryption is not the best way, then what is the best way to store password? This is what we call hashing. This is the most recommended kind of storing the password because this is not reversible. It's called uh, non-reversible hash format. So if I store the password into the database in a hash format, even the owner of the application or even the application itself actually cannot reverse, doesn't even know what the password is. So this provides you 100% security that even, for example, if SIOI is hosted in ISL, even ISL doesn't know, even if they have access to the database, they will never know what is the password of all the customers and the users of SIOI. Now, there are several hashing protocol that we use to implement. Again, maybe some of you hashing is new, but don't worry. A lot of people, some of you are actually familiar with some of the hashing mechanism. So there are two categories of hashing. One is we call the fast hashing, and then the other one is the slow hash. If you look at the fast hashing, I think you're familiar some of it. CRC32. Most of you are already familiar because this is the hashing mechanism used in the file. Probably last few years ago, you might encounter some files getting corrupted and you can see CRC32 error, right? I think most of you are familiar. One of the reasons this was trending, I think most of the password even today are still using the SHA 512. 512 represents the number of bits in the hashing key. This is still familiar today, but this actually becomes obsolete. So probably you are only a few of the developers who are already know or who are already familiar that SHA-512 is not anymore recommended. Why is it not recommended? Because if you have a fast hashing, according to statistics, every month computers are getting faster and faster. You have single core, dual core, octa-core. Now you can even have 16 cores and 32 cores. If you have a very fast hashing, then I can attack the password using the brute force attack. I can just inject different kind of password, and it can be computed probably in the next 30 days or 1 week if I have a very fast computer. That's why it's not recommended. What we can recommend is what we call the slow hashing. Don't worry, this terminology may be new to you, but as soon as you enter into API development, these are very straightforward implementation, and these are actually very safe. So for example, the slow hashing, the very famous one is the big crypt. This becomes the industry standard today, and this will be the same password hashing that we will be implementing. I will give you an example why this is very, very important. There is in hashing, not only we just create a hash of the password, there is what we call the concept called salting. Don't worry, these are technical terms. You might not be able to understand it quickly, but once you start into API development, all those terms are common terminology. So I don't basically expect everyone to right away understand, but once you deep dive, you will become familiar with the terminology. So for example, look at the example in orange table. I have a username, Nakamoto, and a username, Donald. They have the same password. So when we generate a non-salted password, if you look at the hash generated, they're all the same hash. Although it's not visible what is the real password, but it gives the attacker an idea that Nakamoto and Donald, they have the same password because they have the same hash. Right? So it's very clear. So it gives you a clue already that this is actually a security flaw, because it gives the attacker the idea that both the user, they use the same password because they have the same hash. But if in our implementation, we will be using the big crypt with the salting hash, something like this. Okay, so if you look at it, they have the same password, but the encryption, the hash password is different. So it will not only it actually hides the password, it also eliminates the possibility that creates the idea from the attacker that, oh, actually they have the same password or not. It generates, even if they have the same password, it generates a different hash. So it will avoid the confusion. It will avoid giving the attacker an idea of the same password. Because the problem with unsalted hash, for example, by any reason, by any chance, if I can steal the password from Donald, then I can log into the account of Nakamoto because I know that they are using the same hash if I'm using the unsalted password. But if we are using the bcrypt with salted password, even if I can steal Donald's password, I will never know that they actually have the same password with Nakamoto. Is that clear, or you have any confusion?
Yeah, it's clear, sir.
Okay. Now, before I proceed with overview of the microservice architecture, any question on the security, like why are we using hashing instead of plain text, or why? Any question with authentication and authorization, and any basic question?
So far, sir, for me, when you say salted, sir, there's another like key to put in.
Yes, yes, but it's not really a key because the salted is just like a random number generator, something like it's a basic layman's term. It's just an RNG, random number generator, to actually change, but it can be computed in the hash for comparison. The purpose of something is to actually avoid generating the same hash for the same password. It creates a random entity to generate a very unique password even on the same password.
I see. So every user, sir, there will be a random generated.
Yeah, so we call it salting, but salting is normally we don't specify we don't really specify the salting key. The salting is actually computed automatically by the encryption algorithm. For example, in our case, we are using the bcrypt. It's actually the bcrypt that generates the salting for us. So it's being computed internally. We don't have to worry. We just have to specify what we call the salting rounds. How many rounds it will actually generate the, like, if I have a playing cards, it tells you the salting rounds is something like how many times do I have to shuffle the card to make it actually random. Okay,
Understood.
so
Yeah,
if
understood.
I specify salting around is 1, then I shuffle only once, then probably the sequence of cards may be not unique at all the time. But if, let's say, I want to shuffle the cards 12 times, 12 times 12 to 16 is the recommended salting rounds. That means I shuffle the numbers 12 to 16 times, then it's more actually random, more unique.
I see. Okay. Understood, sir.
Okay. Now let's go to microservice. What is really microservice? Probably you're already familiar with API. What is API? It's basically a business logic, but it is actually distributed outside of your application. So in traditional way, the API, which is your business logic, is actually packaged together with the UI. In distributed computing, business logic is separate from the UI. So you can deploy the UI from different server. The API can also be deployed in a different server. But again, I just want to emphasize there are two kinds of business logic. Business logic or the API, which is your core business logic, and there's also the business logic on the UI. Like, for example, already mentioned by Babi-san, like if you have a sales order and you want to compute the total amount just to visualize, that can be computed from the UI side. But there is also business logic in the API side that actually performs the final validation before it can be saved into the database. So we are talking about the business logic on the API side for the implementation of the microservice. But before we do that, let's try to understand what is really microservices. I know there is an API, it performs a business logic, but maybe some of you already familiar with microservices, but maybe some are not familiar yet. So it's actually not easy to understand right away. But let's say, for example, I want to develop a hotel management system. So normally in a hotel management system, you have one service that handles the reservation. So for example, I can reserve a booking reservation or reschedule the booking or cancel the booking. This particular service is totally independent. That means I can perform the booking, but I don't actually need, like, in the hotel system, they have like a restaurant system. You can eat and dine into the restaurant. But the reservation system doesn't really, it's not really dependent on the restaurant system. The reservation system can be deployed on its own. And it actually serves one purpose, that is to handle reservation. But let's just see the overview of a hotel management system. So we have the reservation. We also have the front desk system. Front desk system is when you check into the hotel, you will be assigned which room number you will be given, what kind of accommodation that you will be assigned to you, or do you have access to the lounge. This will be handled by the front desk. Okay. And then you also have a food and beverages. For example, I want to order in the restaurant delivered to my room, or I want just to have a buffet dining or buffet lunch. Then the food and beverages service. So the idea is, in monolithic architecture, all this business logic are stored into one package. But in a microservice, we separate every services into single independent. That means when we say independent, it doesn't rely on any other services. It can run on its own. Okay, so we distribute the different services into one. Now, for example, I want to add one more. We have the reservation, we have the front desk, we have the food and beverages, and maybe we have also the report service. For example, report service generates your billing or print out your billing or something like that. So if you look at all the services and deploy it on the server, the problem is the most heavy, the most hungry, and resource consuming resources probably would be the food and beverages. In a hotel system, a lot of people will be ordering food, a lot of people will be drinking beverages, ordering maybe snacks or coffee. A lot of requests are coming to these services. So what if I have millions of customers and my API is capable only of handling 100,000? What will happen is that because these are independent, I can actually create two food and beverages service and deploy it on two different servers to actually distribute the load. So it doesn't slow down the system because now two servers are running the same services and performing the load balancing correctly. I will explain that later on in the sample scenario. There are different kinds of load balancing, but the idea is, if I distribute into independent services, I can create more of this service to actually automatically adjust depending on the volume of requests. Reservation, maybe not too much user, that's fine. I can create one. Front desk, maybe not so much, but I can create one. But if the volume increase, for the reservation, the system will automatically create a new reservation, which we call auto scaling. Before, we have to manually deploy another one, manually. Now, in a modern distributed architecture, if the volume increase, like for example, the reservation service can handle 100,000 requests per second, but then I have now 200,000, automatically the system will create another reservation service and then run maybe on the same machine or on a different machine, it doesn't matter. It will create two instances and then will load balance accordingly. So the idea, the concept of microservices is even if the number of requests, even if the number of users increase, it doesn't affect the performance because the architecture is adjusting automatically. Now, for example, if I have already 200 requests per second, 200,000 requests per second, suddenly the volume goes down. It becomes just 50,000 requests per second. Automatically, the architecture will close down the other reservation service to free the resources and just run. Can you see the idea? Depending on the volume, it creates a new microservices or it deletes the microservices depending on the volume of requests. You don't have to do anything. Before, you have to do manually. Like for example, maybe in SIOI, this SIOI may be allocated for maybe 1 million requests per second. Suddenly, the volume of this company is very high, so we have to put up another server and then run another SIOI. We don't have to do that manually because that's very time consuming and normally it leads to downtime because you have to create 7 servers and you have to interconnect the data. We don't have to do that manually. We perform an auto scaling, which I will explain later on. Now, just to give you an idea, if we translate this one into actual layout architecture, this is what we are going to implement in our API. This is the overview. Okay. So if you look at this, this is actually color coded. I hope you can see it clearly on your side. So we have the blue box. We also have the red box. And then we have the green box. In production environment, I'm not sure if anyone familiar with Kubernetes?
Not familiar, sir.
Okay. So Kubernetes is a cluster container management. One of the reasons why we use clustering is it can be distributed on different machines, but they work together as one single application. This is how we want to perform load balancing and how we want to perform scaling. But let me just give you an idea. So the idea is in our prototype application, which I will demonstrate later on, we have 3 services. If you look at down below, we have actually 4. So we have the out service, which the only purpose of the authentication is just to authenticate the user. And then we also have the gateway service. And then we also have the core service. You can have as many services as you want, depending on how you want to distribute your services. But in our prototype application, there is one single service to handle the business logic, which is the core services. So core service performs like in our example later on, which I will demonstrate. It's a very basic service that actually creates or save a customer or register a customer, and then at the same time can query the customer information. Okay, so the idea is you have different services down below, and then you have the gateway service. Now, what is the gateway service? Why do we need the gateway service? Remember, all the services can be distributed. By the way, when we say cluster, it can be one single machine, all the services is running inside a single machine, or it can be multiple machines connected together in a cluster. We call it a cluster. So it depends on what is the volume of requests, how many simultaneous user logs into the system. You can actually distribute the different services into different nodes. Okay, so for example, it could be that the core service could be one server, report service on another server, gateway service on another server. It's up to you how you want to use it, or you can put it in one single machine. It doesn't matter, but system is flexible. So if services are actually distributed in different location, I will explain that later on. If they are distributed in one different location, how will the application knows where to find them? Okay, that is where the service registry comes in. So the service registry is actually the heart and soul of the microservice API. So every time there is a new server running, I don't care where it is running, it will register automatically in the discovery service. We call it the service registry. And we are using the NATS. NATS is a messaging platform. So it's an internal, very fast. I think you're familiar with companies like Sony Ericsson, Baidu. These major companies are using this NATS. It's a messaging architecture that allows different microservices to communicate. Okay, so the idea is it doesn't matter where the microservices are running, how many microservices are running, they will be discovered and registered in the service registry. And then it's the gateway that will expose the services outside of your front-end application. Okay, so very basic principle. This is actually a security measure. So in traditional development, most of the business logic and API, they're actually exposed from the outside. I can access them from remote. That's exactly the reason why we have a lot of attack. I think you've heard about denial of service attack, DOS, because most of the services are exposed from the outside, and I can just send requests crashing the system. In our architecture, nobody can access our services because they're inside the cluster. They cannot be accessible from the outside. So question, why, if I cannot access them from the outside, how can the front end access it? That's the gateway service. The gateway service will expose. It acts as your gateway. We call it the edge server. So it's the one that, so every time your front end, you talk to the gateway service, don't worry, I will demonstrate that later on. It connects to the gateway service, and then the gateway service will communicate with the service registry to find what kind of service you need. So for example, I want to print an invoice. So I will send the request to the gateway service, and then the gateway service basically will communicate with the service registry to find where is the report service, and then redirect the request to the appropriate services. Okay, so the idea is don't expose your business logic from the outside to avoid attacks. Keep it inside and only expose the gateway service into the outside. Okay, now question. There is another layer, we call it the reverse proxy. We call it the traffic. I will also demonstrate that later on. So what is the purpose of the reverse proxy? This is the flood control. So for example, if I have so many requests, you can implement policy in the traffic or the reverse proxy to actually block the IP request, even before reaching your gateway service. Okay, so your reverse proxy is the traffic control. So if I have attacks, then it will be blocked by the traffic. So this is the reverse proxy. So reverse proxy is the one that is actually exposed outside. That is the purpose why we have the reverse proxy. So you can implement policy of how you want to control attacks on how you want to control the API. So it doesn't actually overload. Instead of attacker attacking your API, it actually provides a layer to actually block requests depending on the policy that you have implemented. Don't worry, maybe some of you got a little bit still confused of the architecture, but maybe as soon as I explain a little more detail, you'll probably understand the mechanism involved. Okay? Now, there is a concept called load balance. Anyone familiar with load balancing?
Sorry, sir. For me, load balancing is like what you said. It will determine uh, which node to send system loaded.
Yes. So I will explain to you. There are actually several load balancing mechanisms that is supported by our architecture. And I will explain to you. Traditionally, load balancing is very basic. We have what we call the round robin. So, for example, I have a reporting service running on 3 different servers. In a round robin, what we do is just to cycle. Send the first request to server number 1, send the other request to server number 2, send the other request to server number 3, and then 1, 2, 3, 1, 2, 3, just to distribute the load. We call it a round robin, but that is the basic principle for load balancing. But maybe for some people that's fine. But for us, no, we don't do that because that is what we call sort of a manual load balancing. What we are implementing is what we call intelligent load balancing. And I will explain to you, unless you're familiar with intelligent load balancing, but I will explain to you because that is part of our architecture. So for example, one concept of intelligent load balancing is what we call the latency load balancing. The term latency refers to the network ping time, round trip. So for example, if one machine I ping, maybe the round trip for the ping is maybe 5 milliseconds. The other one is 10 milliseconds. The other one is maybe 25 milliseconds. That is the round trip of the ping. So when we perform the ping command, we send a data packet and then wait for the data packet to be back. That's why it's called a round trip latency, because it goes and then wait for the response. So we are implementing a latency-based load balancing. So for example, I am deploying my services into different nodes. I have node 1, node 2, node 3, and node 4. Different report services are deployed. 4 nodes running report services. Now, because remember, we have the service discovery. Service discovery actually keeps track of latency metrics between the services. So for example, based on my location, it determines that node number 1 has 15 milliseconds, then I will be redirected to that server. That's what we call intelligent, because it is based on metrics. So if another user connects to the 60 milliseconds, then that's actually not good for me, because that's a very high ping time. So what the idea of a latency-based load balancing is, give me the fastest server that I can connect. Okay, unlike in the traditional round robin, it doesn't matter whether you're fast or slow server, fast because this is a round trip, 1, 2, 3, 4, 1, 2, 3, 4. If by any chance I was assigned to node number 4, which has a very high latency, not good for me, but I don't have any choice because this is round robin. But in a latency-based load balancing, system will determine which is the server with the fastest ping time for you. Now, take note, people from China and people from the Cebu may not have the same ping time to node number 1. That's why the service discovery will actually holds all the metrics information, and based on your request, where you are from, it connects you to the fastest server. Okay, so this is an example of an intelligent load balancing. It gives you the optimal performance for your user. Another one is what we call the geolocation. Geolocation means, for example, I have one node or another one server for the report service running in Japan, China, and Hong Kong. Now, if I am logging in from Hong Kong, for example, system will know that I am from Hong Kong and I will be redirected automatically to node number 3. This is what we call as geolocation load balancing. That means to give you the optimal performance, you will be given to where your location is located. So Japan user, by the way, you don't even have to do that manually. System will handle the geolocation load balancing for you. So it detects where you are coming from, where you are logging from, and you will be redirected to a Japan server automatically. It's the same used by companies like Netflix. So Netflix user from the Southeast Asia will be redirected to the Southeast Asia server, one in Singapore. But if you are a user from maybe New York, you will be redirected to the East Coast server automatically. You don't have to do that by yourself. It's called geolocation. So it actually assigns you from where you are based. Now, take note, sometimes it's actually a hybrid. For example, if you look at node number 2 and node number 4, I am a China user. For example, Babi-san. Babi-san is from China. Now, when he accesses the server detects that there are 2 nodes in China. Automatically, it will now based on the latency load balancing. So it's a hybrid. First, I identify that user is China, and then this system will detect based on latency which one is much faster in ping time. Is it node 1 or node 4? And then Babi-san will automatically be redirected to the specific node. Can you see how intelligent our architecture is? Not only it detects your geolocation, it also automatically translates to latency-based geolocation. If there are multiple servers in China, it will proceed to do the second layer of load balancing, which is the latency-based. Is it confusing, or anyone have any questions so far? Everyone understand?
For me,
Load
sir,
balancing like latency?
yes, sir, I understand, sir. I don't know about the others. Lo and Brian, did you understand?
For now, it's all
They understand clearly.
Thank you. Don't worry, it's very straightforward. And the most important thing, you might look at it very complicated, but no, you don't even have to write a single code. Our architecture will handle everything for you in a configuration. You don't have to write so many thousands of lines of codes. Systems our system, our architecture will handle that automatically for you. Okay. Now there is one more. That's how powerful our architecture is. There is one even more uh, kinds of load balancing. Resource-based load balancing. System also keep tracks of system resources. So for example, I have a node 1 and node 2. Both of these are in Hong Kong. But the problem is, if you look at the node number 2, CPU and RAM usage is very high. So based on the resource metrics, whoever request comes from Hong Kong will be redirected automatically to node 1 to balance the resource consumption of the server. Okay, so now earlier we have the geolocation, we have the latency, we even have the resource load balancing. Okay, so why is this very important? Very important to implement an intelligent load balancing. The reason why is we want to give our customers, our clients, the best performance, the best user experience there is without so many problem with latency, problem with resource. System will automatically redirect you to the best server that you can connect. That's the power of the microservice architecture. And you don't even have to write code for that. You just have to configure how you want your load balancer to behave. Okay. So yes,
Excuse me, Sir Alex. One thing. Let's say we have multiple nodes for multiple services. Does all those nodes access only one server for the backend side?
now it can be also distributed. So for example, let me go back to our architecture. Now, if you look at here, although it's not represented here, like the core service connects to the database, right? Is your question, is just correct me if I'm wrong. Is your question, is the core service connected to one single database, all of them? Is that your
Yeah.
question? Or
Yes, sir.
don't worry, I will explain that to you later on. We have also a database clustering.
Okay. Okay.
Okay,
Happy.
so so just to give you an idea, because that will be also, I will show you that later on. So there is also in the database architecture, there is also a database cluster. So for example, in our architecture right now, we're using the MySQL. Sometimes people call it MySQL, but most of the people call it MySQL. In the MySQL, there is also a cluster mode. That means database is located on different nodes, and they have master nodes that you can connect into. Okay, so all you have to do is just like in the microservice architecture, you just connect your request to the master nodes. Master nodes can have multiple nodes, multiple master nodes, and it will actually redirect you to the different database available based on your cluster. Okay, and you don't have to worry, each of these database is synchronized by each other behind the scene. So it depends on your policy. Sometimes they synchronize, sometimes they even have something like the database stripping. I'm not sure if you're familiar. So database stripping actually improves performance by, for example, I'm not sure if you're familiar with RAID technology in a hard drive. So in hard drive, if, for example, this particular hard drive, the read-write speed is 500 MB per second. If I perform the RAID, for example, RAID 0, RAID 0 is, I can combine two hard drives. They will not synchronize with one another. but they will be combined into one single volume. That means 500 MB, for example, 1 terabyte and 1 terabyte combined into one single hard drive using RAID 0, for example. They becomes a 2 terabyte hard drive, but the speed is doubled. So from the 500 MB per second, it becomes 1000 MB per second, because you now have two read-write head, two hard drive reading at the same time for reading, and two mechanism for writing. It's called the RAID mechanism. It's also similar in database. You can have a data stripping, or you can simply have a data synchronization. It's a configuration that you can implement in MySQL. Maybe I can show that later on.
Okay, sir. I'll just wait. Sir. Thank you.
Now, I think I already mentioned to you about load balancing. I think you have at least basic idea of load balancing. Now let's talk about there's another one, traffic load balancing, by the way. It's another intelligent load balancing mechanism. See, for example, if you look at the graph, this is actually, if you look at this, it's the unit number of time based on the number of requests. So for example, I have 5 nodes. If you look at node number 1 versus node number 2, node number 1 is the red. Node number 2 is yellow. Now, if you look at the node number 1, on every 25 seconds, it has an average of 100 requests. On the other hand, node number 2, on 25 seconds, it has an average of maybe 50, 60. So what the traffic load balancing means is, for example, one server or one node has maybe 1 million requests at the moment, then definitely I will not be forwarded to that particular node. The system will automatically find a node, for example, node number 5, which has a very low request rate. Okay, we call it a traffic. Request rate is how many traffic is running into the system. 1,000 requests or 1 million requests per second on node number 2. Node number 1 is 1 million requests per second. For example, node number 2 is only 5 requests. Then based on the traffic volume, I will be redirected automatically to node number 2. Okay? Something like that. So based on the traffic, I will be redirected also to the less traffic server or node. Okay, you got the idea? So less traffic, I will be given a redirection.
Yes, sir.
Okay.
Yes, sir.
Let's go to scale. Anyone know what is an auto scaling, or what is scalability?
For me, sir, the auto scaling is like the system would automatically create a new instance of the server.
Yeah. Okay. So
If
there's manual scaling, and there's also the auto scaling. Anyone familiar with? First, let's try to define what is scalability.
Scalability, basically, if it is measurable, something like that.
Okay, so scalability by definition is the ability of the system to adapt to the volume of traffic. Okay, so for example, I have one server, SIOI server, and it has, for example, 1 million requests per second. It's working fine. 1 million requests per second. It's working very fine, perfectly. But then suddenly, the volume of requests goes to 2 million requests per second. And then the customer complains. It's beginning to be very slow. And then suddenly it goes to 3 million per second. Our customer gets angry and called Josephine, Josephine, what happened to our server? Because the system doesn't apply scalability. That means it's not scalable enough when the volume or the traffic increase. It doesn't adapt. It's the ability for the system to adapt to the volume or the traffic. Now, there are two kinds of scalability. One is called the vertical scaling, and then we also have the horizontal scaling. Now, what is vertical scaling? Vertical scaling is the traditional way. So what the vertical, the horizontal and vertical, right? Vertical means up and down. Horizontal is left and right. Vertical scaling means if the request is normal for 1 million requests per second, now it goes to 2 million and it's slowing down. Vertical scaling means let's try to add memory on the same machine. Okay, so we increase the memory from 16 gig to 32 gig. Still, it's very slow. Now let's try to extend from 8 cores to 16 cores. Or maybe it's still not enough. So maybe we update to SSD storage from maybe 1 terabyte to 2 terabyte. That is concept of vertical scaling. The same machine, but we just keep on increasing up, vertically up. Add more memory, add more CPU. That is what we call vertical scaling. And it's not very effective actually. It's maybe for non-high volume kind of customer, that's fine, but it's not highly recommended if you want to implement a auto scaling. So what we are doing is we call the horizontal scaling. Horizontal scaling is instead of adding memory, the system will automatically add another instance on a different server. It's called the horizontal scaling. That's one of the characteristics of a distributed application. That's why it's called distributed, because it can auto scale on as many servers as needed. And you don't have to do anything about that. You just define the policy. Like I want the policy to be like 1 million per machine, and if the request goes to like 10 million, auto scale right away. And that is what we are implementing in our system. So in Kubernetes is a cluster container management system. We can define a policy of how we want to auto scale. Just a visual idea. Let's say I have a node number 1, report service. And I want to define a policy that this node number 1 should be able to handle 1 million requests per second. Now, based on the Kubernetes policy, if it goes beyond 1 million, it creates automatically node number 2 on a different machine. Automatically, you don't have to do anything. You just define the policy of how you want the auto scale to behave. Now it goes to 3 million, so it creates node number 3. And now it has 4 million, it goes to node number 4. And finally, we have 5 million per second, it goes to node number 5. Automatically, the system adapts based on the volume, so that what will happen is that every user out of the 5 million user will have a very smooth user experience. They don't they don't experience lag, they don't experience delay, very slow response, as if nothing happens. It's just like, regardless if there's 1 million user or 5 million user experience should be the same. So what will happen if the user now goes to 4.5 million, automatically the system will remove and remove and remove and remove until it goes to the minimum. So in the policy, you define the minimum number of nodes that should be running. Okay? You don't have to do that. You just have to define a policy. We call it the deployment policy in Kubernetes. And then question, since these are dynamic servers, how will the system know where to connect? Which nodes are located? Remember, we have the service discovery. The service discovery is the answer, because every time there is a node that pops up or registered, it registers to the service discovery and it becomes discoverable. And the service discovery also keeps tracks of the metrics, where they are located, the location, what is your ping time. All those information are being recorded by the system. Okay? So this is auto scale. You don't have to write a single code. You just have to define the policy of how you want to define auto scaling. Any questions so far on the microservices, the features, load balancing, scaling? Any questions so far?
Hello again, sir. This is Lou. There is just one thing I am concerned about. It is
Yes.
regarding, correct me if I'm wrong, sir. What I have understood about the nodes and the, the balancing is that, is it that every node have its own server, shall we say server?
It depends on how, and once you deploy in a Kubernetes, in the Kubernetes, you define how many nodes. Okay, so
Okay, sir.
I can have.
Okay, sir. Carry on. Sir.
Yeah. So in Kubernetes, I can have. That's why there's a distinction between a node and a server. In Kubernetes, you define remember, Kubernetes is a cluster.
Yes.
You can define as many nodes as you want. So for example, if I decide to have a single node cluster, okay, because limited in budget, I only want to have a single node cluster. But the problem is, I still want to define that 1 million is a single node. Okay? What if it goes to 2 million? So the Kubernetes cluster will actually create node number 2 on the same machine, but they will be running on different port number. Okay? You got the idea? One single server, you have a report service running on one single server, but running on different ports.
Alex.
Yes.
Maybe I have the. I like to have some question.
Yes.
Yeah. The Kubernetes is the manage of the Docker container.
That's correct. So in Kubernetes is the cluster orchestration engine. Inside the Kubernetes, everything that is running service, you have the ingress and ingress, are all Docker containers.
Yeah. Yes. When you need to horizontal scaling, requiring another server node, so the Kubernetes will automatically establish the another Docker node, isn't it?
That's correct.
Yeah. So this Docker container, including of the OS layer and application layer, isn't it?
That's correct.
Yeah.
Normally, I will explain how Kubernetes works. So when you deploy a Kubernetes is the orchestration engine, and there on top of that, you have your cloud platform. For example, you might be using AWS, you might be using Google Cloud or IBM Azure. Within the Google, for example, within the cloud platform. By the way, it doesn't really have to be cloud platform. It could be self-hosted, but you have to define your own orchestration engine. So what will happen is that when you deploy Kubernetes, for example, at AWS, when you specify that how many nodes you want to implement, the Kubernetes actually communicates with the AWS to actually create automatically a VM instance if you want to do that. Sometimes another configuration is there are already defined VM, like for example, if you want to implement an ISL, you define like 4 VMs and you register those 4 VMs as a node in the cluster. So that is what we call a static cluster because all the VMs are already preset. So I have 4, that will be 4. So if I want to have a dynamic, then the Kubernetes can also execute a script to automatically register a VM for you. So many configuration in Kubernetes. Go ahead, Babisan.
Yeah. I suppose the maybe Chris, can you ask the engineer that everybody understand what is the function or meaning of Docker container?
Okay, sir. I think Lou and Brian. Oh, I think all of us
Understand
also we have no experience of Docker.
Oh, yeah, right. And maybe, Alex, that's the main point that last time the engineer's question, because they think that the Kubernetes will generate the node directly, but actually Kubernetes is depends on the Docker container to generate the node. And what is mean of the Docker container is maybe can you explain the a little more detail of what is the Docker container?
That's correct. Maybe it's a little bit confusing, but let's put it this way. There are 2 layers. Maybe I'll go back to the diagram. If you look at here, we have the green. Can you see the screen?
Yes, sir. We can clearly see this.
So if you look at if you look up here, there's a sub-layer. So there's a green box, and then we also have the red box. If you look at the Kubernetes cluster diagram, it's outside the red box. If you look at the red box, inside you have your services running in the Docker. Inside the red box, inside the Docker container, the Docker has its own networking. That means it's Docker, something like that each Docker can run on each different node by itself. And then at the same time, there is also the Kubernetes cluster, which has its different nodes, virtual nodes. And each Docker container, its Docker images that is running can be put into one of the Docker node. Okay, so for example, just to avoid a little bit of confusion, if I have a single node Kubernetes, that means one single virtual machine inside the Kubernetes cluster, I still can run multiple Docker nodes inside. Meaning, inside the single node, I have report service, I have the report service, core service, and the authentication service running inside one single node. But they are actually running on the different instances. Okay, is that a little bit confusing? So one single machine can have one single Kubernetes node can actually run multiple different Docker images, Docker container inside. Is it confusing or?
Chris,
Yes, sir.
maybe you can think like that. First of all, you set up the OS, let's say the operation system, and then you set up the let's say if it is the web server, then set the web server environment
Mhm.
on the virtual machine, virtual server, and then you maybe how to say compile or you make it the Docker image.
The
Docker images first. Docker is the container service. The container service is the it's very similar like the virtual server.
Okay.
The virtual server.
Like a virtual
Yeah.
host.
Okay.
Yeah. Yes. If you run the virtual server under the VMware or other virtual systems like Microsoft Hyperledger, those are the virtual machine,
Hypervisor.
virtual machine systems. Then and virtual machine environment, and on the top of the virtual machine environment, you set up the virtual server. Then you set up the operation system. You set up the let's say web server environment, and then you generate the Docker image.
Okay.
And so the Kubernetes is holding of the Docker images of the web server, including the OS layer and application layer. And then, yes, when the Docker was recognized that the existing server node, web server node, is the let's say not enough the capacity, then the Docker will release the Docker image packages. Then let's say it will come out the another web server web server node.
Nice.
Maybe you can just image like that. Maybe for the network engineer point of view, a little bit more, maybe a little bit different. But based on the application programmer's point of view, you can maybe now you can temporarily understand like that. Yeah. Okay. Alex, I give back to you. Then you please continue.
Okay. Okay. So this is auto scaling. Unless any question, then let's look at the next subject matter. Any questions so far?
None, sir.
Okay. So the most important thing when you define an API is you define a protocol on how your API will communicate or how the external clients will communicate with the API. So I am proposing a very basic communication protocol when initiating the API. So I have this response structure. So every time you request send a request to the API, it should respond with a standard API response structure. it should be something similar to this one. Okay. So when I send a request, it should respond with 4 basic elements: code, which is your response code, description, the date of the response, and data if there are corresponding data to execute. But if you look at the architecture, on top of the response structure, it should give priority to HTTP code uh, as the top priority response code. So for example, if you got error 404, HTTP code 404, that means it's resource not found. The idea is it doesn't actually reach to your API service yet. It's actually the HTTP server that is responding the error 404. So it always takes on priority. That's why it's on top. But as soon as it reaches your API, then we will follow this basic structure. So every time you call the API, it will always respond with this format: code, description. Response code means you can take control. Like 100 is success, maybe for example, or minus 100. Normally we denote the negative to be uh, error or something, but it's up to you how you want to define. So for example, if maybe minus 100 is record not found, or maybe minus 200 is uh, error in generating report. You can define as many error codes, just like HTTP code. Like HTTP code 500 is internal server error. It depends on how you want to define. You just define the code, but you just follow this very, very basic structure. Code, which is your response code, description, just describe what is the response code all about, and the date where the process has been completed, and of course, data. This could be empty if you are not returning any data, or you can simply return any kind of uh, uh, object format here. By the way, may I ask, everyone familiar with the JSON format?
Yes, sir.
Okay, that's very good. So most of the recommended format for API is JSON, although you can still use XML, but it's not really recommended at this point in time. I still would recommend we go for the JSON format for all the API. Okay?
Okay.
So this will be the end of the first session. Uh, let's have any question and answer before we proceed with the technical demonstration.
Uh, okay. Yeah, please continue.
I'll stop the recording and then let's go to the Q&A. Or do you want to include the recording, Bamsan? Q&A?
Yes, include.
Okay. Any questions so far?
Brian, no, do you have any questions?
Hello. I have some questions.
Yeah,
Yes.
please, Brian.
What if, for example, if I have other database cluster, maybe like connected in the like the other cluster, and what if I make another database cluster? Is it possible? Because maybe the one in the database cluster might be down, and it is possible to
Actually,
database
it's
cluster.
like this. That's a valid question. So it's the idea is actually one single cluster can have multiple database nodes. So if one of the database node is down, automatically you will be redirected to the other nodes. So one cluster itself already has multiple nodes up and running.
Okay. Thank you. And another one is the geolocation.
Yes.
Geolocation. What you call that? Load balancing. What if I'm
Yes.
using VPN? what if I'm using VPN, like if I'm in China right now and I'm using Japan, VPN Japan, and is that uh, the load balance can detect if I'm using VPN?
And normally, the way it behaves is it always takes the VPN IP address as the exposed IP address. So it will, if you are using VPN to access, then depending on your VPN server location, you will be redirected to that particular. One of the reasons for that is, remember, if you are using VPN, it's actually your VPN that is requesting the data to the server on behalf of you. So to give the best performance, it always takes the VPN's IP address as part of the geolocation.
Oh, I
Because
think
otherwise, because otherwise, what will happen is that even if you are in China and you are using the US VPN, and then if it detects you are in China, since you are actually connected in VPN, all the traffic still goes back to your VPN server and sends back to you. So it's actually more uh, additional round trip.
okay, I see. I think
Um,
I think that's all for me.
yeah. Hello.
Yeah.
Yes.
Yeah. Um, the I was requesting Alex to we allow to use the cluster version of the MySQL. But for for our for our application, it means we are considering of SIOI, and SIOI is the business application such as the sales order, purchase order, inventory data, um, and actually there are a lot of the our system is based on the data to transact the work, right? In that case, we are not easy to allocate the database in different locations. Even we set up the cluster because of the there are huge amounts of the data need to be synchronized between the one cluster to the other. But if you think about the other application, like the database is only used for the authentication purpose. In that case, user ID, password, maybe some of the some other user information. So the volume of the data is quite a little. If that is the case, we can put the how to say the database in the let's say cluster. We can set the main database in Hong Kong and one database in China, one the other database in the United States, or one is in the Europe, and based on the user's location to choose which uh, uh, which database is close to the user's physical location. Um, Maybe we can think about this kind of the application in some other purposes. But
That's right.
come but come back to our SIOI. We have the huge number of the database transaction data. So although we set up the cluster, but usually, we will set up the database in the same location, or at least within Hong Kong, something like that.
And also, I would like to add the decision to define the cluster Normally, it really requires based on the volume of transaction or the traffic. So for maybe some customers, doesn't really require clustering, single database, as long as there's a systematic backup system implemented. It doesn't really mandatory to have a clustered environment. So it's optional. It's a management decision to decide. So what I'm trying to emphasize is it's not mandatory to be able to implement cluster, but our architecture is cluster ready, but it doesn't have to be required.
Alex, I long time ago you explained me. Is it the some of the cluster setup? Can we assign the some of the cluster nodes as read only?
Yes, there are read-only. Basically, one of the purpose for a read-only cluster is actually to speed up the reading of information.
Right.
So this is only like if you are searching for information behind the scene, this database actually synchronized with the main database, but this particular instance is not actually allowed for writing. It's just for read. So it offers you the performance, like maybe twice or thrice the speed of reading information in the database, but it gives you the prohibition to be able to save information, except for the synchronization.
One of the
In fact,
one of
yes,
the heaviest SIOI transaction is the reporting.
hmm.
So
In fact, Barbisan, depending on your platform, in fact, if you're using AWS, if you want to create a read-only node in the cluster database, it's just actually one click. There's an option there, one click, AWS, to actually create as many read-only database as you want. So most of the cloud platform now already provides those facility for you to use.
yeah. At this moment, not really sure yet. We for the SIOI, we will use the physical server or the ISL IDC has the virtual servers environment. Maybe or maybe we will mix it together. Maybe database node we will set into the our own hardware servers, and then the API server will be located into the virtual server side. So maybe
But
we
by
will
the way,
consider.
you have another team handling the database administration, Bamsan?
No, I think database administration basically be assigned to the Chris.
Oh, okay.
Yeah. But of
That's
course,
fine. That's fine.
yeah, we have the network team. If we set up the virtual server environment, the we have our ISHK has network team, and they are setting up their own virtual server environment.
Okay.
Whether we can mix it together or maybe totally separate. Think about it.
Okay.
Yeah.
Any questions?
Okay, then stop the recording
Yeah.
and maybe start another recording for technical
Yes.
session.
But yeah, before I stop the recording, I just want to emphasize probably much of these information technologies are probably new to everyone. So don't worry, learning takes time. Nobody can actually learn all the technologies overnight. It's a learning process. So the only way you can actually learn is to actually practice it. Like, like read resources, try to deploy cluster, try to learn on your own. It's a learning process. So
Yeah,
basically,
yes.
it's not an overnight experience.
The on-demand link
Yes, sir.
or the on-demand
Maybe we should
education
start
will only
to learn first about the Docker, sir.
Yes, you can start learning the Docker, uh, and then later on, I'm not sure if everyone already familiar with Node.js. Maybe you can also explore that part, and then
Yeah.
slowly you will understand. And then along the way, you will also learn different terminologies like JWT, JSON Web Token for authentication, and all those stuff. You can actually learn it along the way once you start learning Node.js and something like that.
So, Sir Alex, so if we need to start from the beginning, we should learn Docker, right?
Yes, but since Docker is an orchestration, you need a something to orchestrate. That's why either you use Node.js.
Node.js,
So
yes.
first, you have to be familiar with Node.js because it is actually the source where you can compile into a Docker image. Because if you're
Okay.
just learning Docker and there's nothing to actually create an image from, and also doesn't make sense.
Yes,
So
yes, yes.
learn first maybe Node.js. By the way, later on I will do the technical demonstration. I will give you full access also to the server. I will keep it running for a few weeks. You can feel free to access, anyone can access the server. Uh, Feel free to explore, feel free to experiment. I will keep it running, or you can create your own on your local machine or create your own server, but I'll keep it running for reference for everyone.
Okay, okay. Thank you.
I'll stop the recording now.